upgrade from 2005 to 2014 and some of the benefits that we can get right away. I'm connected right now to a demo machine that has two instances. I have one instance with SQL Server 2005 SP4, which was the last SP4 released for SQL 2005, and I also have SQL Server version 12, which is SQL Server 2014. In this case, I've also applied Service Pack 1, which is already available for 2014, so both versions are in their latest service pack. Now what I'm going to do is I'm going to take the AdventureWorks database and restore it from the SQL Server 2005 into the SQL Server 2014. So you can see it's just a straight up normal restore statement. There's nothing special to specify when you're doing the version upgrade. Let's look at the output now of the version upgrade. We can see the amount of percentage that the restore was processing, and then we can see also the output of the different upgrade steps that move the database from the different versions all the way up to 2014. We can also see here that we get some warnings related to XML. The restore process will flag down any type of warning that it detected during the upgrade process. In this case, we can see that there are some invalid values in some XML that are not going to be valid in SQL 2014. It's a fair warning so that at the time of restore you know that you might have some specific issues with this particular index or table. We can see after the XML, the rest of the upgrade steps are run, and then at the very end, we'll be able to see the message saying that the restore was completed. It means now the database has been restored and mounted on our SQL 2014. And we can open it up and verify it, and we can see AdventureWorks has been restored there. Let's look now at a comparison between the AdventureWorks database and the AdventureWorks database in 2014. In this case, the only difference is that I've created a clustered column store index in the 2014 version. You can see the instruction there, create clustered column store index on a table called Big Transaction History. This table is fairly large, so we want to measure the improvements we get on space and performance by applying the column store index technology that we now have available in 2014, and we definitely did not have back in 2005. Let's verify the versions. We can see I'm running SQL Server 2005 on the left side of the screen. I'm going to run the same on the right side of the screen. And we can see there I am running SQL 2014 on the right side. So all the results that we're going to get on the right side will be from 2014. On the left will be from 2005. So to continue to verify the exact same setup, we can see that the max server memory I'm using on both of the instances has been limited to 2.5 gigs. As you can see there, I have the configuration value for max server memory to 2,500 megabytes on both instances as well. So it's not an issue of having more memory or more hardware resources that's going to help with this particular query. It's a matter of simply the better technology with the column store indexes. We can look as well as to the size of the different tables on the different versions. One that is just doing the normal disk-based table, and the other one has the column store index. Let's look at the size comparison. The regular disk-based table is 31 million rows and about 2.2 gigabytes of storage, divided by 1.1 of data and another gigabyte of indexing. The 2014 version with the clustered column store has the exact same amount of 31 million rows, but you can see that the space used is only 350 megabytes. This is a great improvement over the 2.2 gigabytes that we were using on the 2005 version. This is due to the column store compression. Now to make the comparison fair, I'm going to drop the clean buffers, so the I/O has to be done and nothing is cached in memory. Now I am going to be running a query that is basically going to compute the sum of the quantity and costs of the orders in this big transaction history table. And we're going to see the difference between the classic implementation with the classic index and the column store implementation. Let's run the 2005 version first. And we'll see how long it takes and the execution plan compared to the 2014 version. So it is done now. It took about 28 seconds. Now we're going to run the 2014 version. And it is done now, and it took 13 seconds. So we can see we get over 50% improvement by using the column store technology, and on top of that, we're using less space on the disk. Now we can also check the execution plan and look at the differences there. Notice how the classic execution plan in 2005 was doing a regular index scan. So we can see that we did read 31 million rows because it was required by our query. And the execution mode says row because it's a classic disk-based table. It is not a column-oriented column store index. Now let's look at the difference in the new execution plan in 2014. We can see the operator now is a column store index scan. It is also reading the 31 million rows, but the storage now says column store and the execution mode says batch. Batch mode is a faster execution mode that pushes groups of rows through the CPU at once instead of one row by one row into the CPU like the regular row-based mode. This also changes how fast the query runs because more rows are passed through the CPU faster than a normal table. Now that we've seen the difference in the speed and space of a table, let's compare the differences in just doing a regular backup. I've done a backup of both AdventureWorks copies, the 2005 and 2014, and I'm going to compare here now the time and the database sizes of the backup from the 2005 to the 2014 version by querying the catalogs on MSDB. So you can see from the result, the 2005 produces a 2.3 gigabyte backup that took about 8 minutes to generate because of that big transaction history table. On the 2014 version, not only have I reduced the size of the big transaction history table, but now I also have backup compression enabled. So the AdventureWorks backup on 2014 shrinks down to 481 megabytes and only took 2 minutes to run. This is about a 25% of faster backup than before. It only took 1/4 of the size and 1/4 of the time. So this is also a manageability and space improvement from 2005 to 2014 with very little change from our side.